Hello, my name is Zaria Parekh and I'm roll number 38 from group number 5. Today, we are going to present our poster on the Six Sigma software quality management. We are going to brief you about the DMAIC, which is nothing but define, measure, analyze, improve, and control version. Now, this particular model is very much helpful for the quality management of an existing software. So, a software that is already in the market and is only limited to further improvements. Later, we are also going to discuss about the advantages, the disadvantages, and the industry application of this particular quality management model. So, let's dive in. Firstly, the Six Sigma approach finds its origin at the Motorola company in the mid 1980s. The Six Sigma model is a fact based, data driven philosophy of quality improvement that values defect prevention over defect detection. So, what does that mean? The Six Sigma quality process, implies that there cannot be more than 3.4 defects per million opportunities, which is almost zero margin for error while development. Now, I'm going to hand it over to Rohit, who is going to explain you further about the define and the measure quality processes. Over to you, Rohit.
This is Rohit, roll number 26 from group number 5. I am going to speak upon the first three steps, that is define, measure and analyze of the Six Sigma software quality management. DMAIC refers to a data-driven improvement cycle used for improving, optimizing and stabilizing business processes and designs. The DMAIC improvement cycle is the core tool used to drive the Six Sigma projects. The first step here is define. It stands for defining the problem, the customer, the project requirements and the ultimate goals and expectations of the customer. The purpose of this step is to clearly pronounce the business problem, goal, potential resources, project scope and high-level project timeline. The second step is measure. It stands for measuring the performance of the current process by establishing a data collection plan to determine defects and gather metrics. The purpose of this step is to measure the specification of problem or goal. This is a data collection step, the purpose of which is to establish process performance baselines. The performance metric baseline from the measure phase will be compared to the performance metric at the conclusion of the project to determine objectively whether significant improvement has been made. The third step is analyze. It stands for analyzing the process to establishing the root cause of variations and defects to identify the issues with the current strategy that stand in the way of the end goal. The purpose of this step is to identify, validate and select root cause for elimination. A large number of potential root causes of the project problem are identified via root cause analysis. The top 3 to 4 potential root causes are selected using multi-voting or other consensus tool for further validation. The next two steps, that is improve and control, will be explained by Shreyansh. Over to you, Shreyansh.
I am Shreyansh Kapasi, roll number 25. The fourth phase of Six Sigma process is improve. At this point in the project, the team has identified possible root causes of the project. The improve phase should identify, implement, and validate corrective actions to resolve any process issues and improve performance. This can be done in 3 steps. The first one is to identify potential solutions. The team should identify possible process improvements that would increase process efficiency, improve quality, and operator safety. Brainstorming is commonly used to generate a list of potential solutions. This can be done with the 5 how exercise. The second step is to analyze failure modes of proposed solutions. Consider reviewing potential improvements for the risk and possible impact on other processes. A failure modes and effect analysis (FMEA) is often completed prior to implementation of any changes. The FMEA helps the team identify and address potential problems that may arise due to improvements to the process. The last step is to validate improvements. Prior to implementation, any process improvement should be validated using statistical methods. The team must verify that the improvement resolved the issue. Validation may be achieved through pilot builds, data collection and analysis, and/or creation of a future state process map. The last phase of Six Sigma process is control. The objective of the control phase is to support and maintain the gains realized during the improve phase. Proper action must be taken to assure the process does not regress back to its previous state. In order to achieve this goal, the team will need to take the following steps. First, update process documentation. The team must ensure that all process documentation is updated with the changes to the process due to improvements implemented. Second, associate training. Assure that all associates are trained on the process and understand the improvements that were introduced and how it affects their responsibilities. The associates should be informed of the purpose of the changes and the benefits of making these changes. Third, implement statistical process control (SPC). SPC will monitor performance of key steps in the process that relate to the CTQs identified during defined phase. The control chart should be updated on a regular basis. Fourth, create a process monitoring plan. This is one key area where Six Sigma sets itself apart from basic project management. The purpose of monitoring plan is to document how the performance of the process will be monitored over time. And the last step is to celebrate. The team should celebrate the successful completion of the project. Once the control phase tasks have been completed, it's time to transfer ownership of the new process to the original process owner.
This is Manan Ashar, roll number 42. Now we shall see the advantages and the disadvantages of this method. Advantages. The key advantage of Six Sigma approach is the threshold of the quality control that is needed to implement it successfully. The level of defect reduces drastically in this while approaching this method. The Six Sigma approach stresses upon the entire process rather than just focusing upon the outcome. This helps us gaining key insights where defects can originate. Six Sigma promotes a long-term capability of resourcefulness and solution. Additionally, it provides a strategic direction to the problem-solving needs of the company. As the implementation of Six Sigma makes it necessary to remove the defects in the end products, the business develops customer satisfaction and trust. Six Sigma has high acceptance rate in the corporate world because of the successful implementation of this methodology in diverse companies and industries. Some of the limitations of Six Sigma approach are as follows. The idea of Six Sigma is complex and well-disciplined doctrine. It makes difficult for a manager of mediocre knowledge or lacking relevant management knowledge to understand it properly. The approach presents a variety of changes that a business must undergo to implement it effectively. This increases the bureaucracy and rigidity in the system of business. Six Sigma requires ample of attention and commitment from the management of the company. Six Sigma requires a considerable amount of resources, both human and financial. Due to high cost, it may be difficult for small business to implement it. Some of the industries which have implemented Six Sigma approach are as follows. Healthcare industry. Pharmaceutical companies have turned to such practices of quality by design to ensure the best results in manufacturing drugs, including meeting safety standards and product effectiveness. One study found out that 87% of healthcare organizations saw improvement in patient score after implementing process improvement methodology. Another industry is software industry. Technological companies striving to remain competitive in constantly evolving market must focus on efficient process and speed to market. Many companies have implemented this methodology. One early adapter was Wipro. Initial result included a 91% on-time project completion as compared to the industry average of only 55%. Microsoft and Motorola also have implemented this approach. Oil and gas industry. Another mature industry turning to Six Sigma is oil and gas industry. With overall industry facing a downturn in recent years, Six Sigma methodology have helped keep some business profitable in tighter economic times. One example is Colorado-based UE Compression, which uses Six Sigma to reduce process cycle time and improve quality of air and gas compression products according.
We hope you liked our presentation and the poster. Thank you.